Alright, welcome back everyone. So a lot of this is going to be similar to the previous video. Here I've already drawn the restricted domain for cosine and the range. So if you gave cosine an angle in that restricted domain, it'll give you a number in that range, and cosine inverse will take you back to the start. If you give cosine inverse something in its domain, then cosine will return you back to the start again. If you give cosine inverse something that's not in its domain, then cosine inverse is undefined, so there we go. And finally, if you were to give cosine inverse something that wasn't in this domain, it'll still give you a number between -1 and 1, but cosine inverse will return an angle that's between quadrant 1 and quadrant 2, somewhere between 0 and pi. So the first two problems are fairly straightforward because the number that we're putting in is a number in the domain of cosine inverse. So since -0.87 is in that domain from -1 to 1, then when we put it into cosine inverse and put our output into cosine, cosine will return our original number back to us, -0.87. Similarly, for the second example, we're looking at cosine of 3 pi over 4 as being on the inside, and for that, 3 pi over 4 is between 0 and pi, our restricted domain, so we put it into cosine, and cosine inverse will give us our original angle back of 3 pi over 4. Now, for something like 7 pi over 6, which I'll just do a quick little sketch here, pi is the same thing as 6 pi over 6, so 7 pi over 6 should be a little bit more than pi. And if pi is the same thing as 6 pi over 6, then 7 pi over 6 should be pi over 6 past the x-axis. So in other words, our reference angle should be pi over 6. Now that means that we are in quadrant 3, and in quadrant 3, cosine is negative. Cosine inverse, of course, is only going to give me something in quadrant 1 or quadrant 2, and since cosine of 7 pi over 6 is negative, cosine inverse will give me an answer that's in quadrant 2 because that's where cosine is also negative. So that means that the angle that I'm talking about is going to be one that's in quadrant 2. It'll have the same reference angle of pi over 6, so that means the angle that we're talking about really is 5 pi over 6. So since cos of 7 pi over 6 and cos of 5 pi over 6 are equal to each other, and we know they're equal because they both have the same reference angle and they're both in quadrants where cosine is negative, and since 5 pi over 6 is in that interval from 0 to pi in my range of cosine inverse, then it's 5 pi over 6 that I'll get as my output. Next one is pretty fast, because of course here we're looking at putting a number into cosine inverse, or arc cosine, and since the domain for cosine inverse is from -1 to 1, the number we're trying to put in is not inside that domain, so cosine inverse is not defined, which means the entire thing is not defined. So our answer is, this is undefined. Lovely. Let's continue on. One more. Cosine inverse of cos of 7 pi over 4. A full circle, 2 pi, is the same thing as 8 pi over 4. So 7 pi over 4 is just a little bit less than a full circle. And pi over 4 should be the reference angle. So we are in quadrant 4, and in quadrant 4, that's where cosine is positive, and of course cosine inverse is not going to give us an angle in quadrant 4, it gives us angles in quadrant 1 or 2, but since cosine of 7 pi over 4 is positive, then we'll get our answer in quadrant 1, where cosine is also positive. So the angle that we'll be talking about will be in quadrant 1, with reference angle pi over 4, or in other words, we are talking about pi over 4. So cos of 7 pi over 4 is equal to cos of pi over 4, and that's because they both have the same reference angle, and they're both in quadrants where cosine is positive. So since pi over 4, since that is in my range for cosine inverse, then that means that pi over 4 is going to be my output, when I use 7 pi over 4 as my input. Next part is pretty much the same as when we introduced inverse sine or inverse cosine. So again, we've restricted our domain, and here we're restricting our domain for tangent to being in quadrant 1 and quadrant 4. And the reason for that is in quadrant 1, that'll give us the positive values for tangent, and in quadrant 4, that'll give us the negative values for tangent. Now, the one thing that you might notice here is that my restricted domain doesn't include negative pi over 2 or pi over 2, and you might be wondering, why are we not including that? We did for sines. Sines' restricted domain was negative pi over 2 to pi over 2, including both. But for this one, why are we not including them? Well, we should remember from the graph of tangent that there's vertical asymptotes at negative pi over 2 and also at pi over 2, which means we don't actually have tangent of x defined at either of those 2 points, which is why we're not including them in our domain. Same thing that we said before, of course, whatever the domain of tangent is, that's the range of tangent inverse. So the domain of tangent from negative pi over 2 to pi over 2, so the range of tangent inverse, same thing. Now here's something nice. Since the range for tangent is all real numbers, unlike sine and cosine where there was a maximum and a minimum value, for tangent it goes up to positive infinity and down to negative infinity. Since that's the range for tangent, then that means that's the domain for tangent inverse. So the nice thing here is you can put any number you'd like into tangent inverse and you can always evaluate it. Unlike cosine inverse and sine inverse, which were both only defined from -1 to 1. All right, let's do some evaluating. Some of this we can remember from our graphs. If we're thinking about the graph of tangent, we should remember that tangent of 0 is equal to 0, and that's because if we're looking back at our graph of tangent, when x is 0, y is 0, or in other words, the point that we have at the origin. So since tangent of 0 is 0, that means tangent inverse of 0 is also 0, switching our inputs and our outputs. Arctan of -1, or in other words, tangent inverse of -1. So this is where we'll need to do a little bit of remembering that that number we've seen before showing up in when we evaluated an angle in one of our special triangles, specifically the 90, 45, and 45 triangle. So when we have the angles pi over 4, pi over 4, and pi over 2, the side lengths were 1, 1, and root of 2. And we'll remember then that tangent of pi over 4 should be opposite over adjacent, 1 over 1, which is 1. So you know that pi over 4, that would be something where tangent has a value of +1, and so then that in quadrant 4, negative pi over 4, that would be the value angle where tangent has a value of -1, because that's the quadrant where tangent is negative. So we know that tangent of negative pi over 4 is -1, so that means tangent inverse of -1 should be negative pi over 4. There. All right. Couple more. Tangent inverse of -√3. This one, if we're remembering from our 30, 60, 90 triangle. So there's 90, 30, 60, or pi over 2, pi over 6, pi over 3 for the 90, 30, and 60. Side lengths 1 opposite the pi over 6, root 3 opposite the pi over 3, and 2 opposite the 90 or pi over 2. Okay, so if we're thinking about this triangle, if we were looking for a value of tangent of root 3, that would happen if we were looking at the angle of pi over 3, because tangent of pi over 3 would be opposite over adjacent, root 3 over 1, which is just root 3. So we know then that tangent of pi over 3 is root 3, but that's not what we want. We want negative root 3, but we know then the equivalent angle in quadrant 4 would be tangent of negative pi over 3, that would give us a value of negative root 3 for tangent. So since tangent of negative pi over 3 is negative root 3, then that means that tangent inverse of negative root 3 is negative pi over 3. All right, last one. Tangent inverse of 807. This isn't something that's coming from one of my special triangles for sure. So that means that it's time for us to grab our calculators, make sure that we're in radians mode. Second function, tangent 807. And when I run that through my calculators, I get about 0.1569557 and so on. We were going back to 3 decimal places, so I will round that to 1.570. All right, and this is a lot of the same thing that we said before, that again, if we're thinking about the restricted domain of negative pi over 2 to pi over 2 and the range of negative infinity to infinity, how tangent will take an angle and give us a real number between positive and negative infinity. Tangent inverse will take any real number and give us an angle between negative pi over 2 and pi over 2. So a lot of the things that I said before are again true here. If you take something in the restricted domain for tangent, then tangent inverse will take you back to that angle again. Take any real number. This is the one that's kind of nice. Take any real number. You can always put it into tangent inverse. It'll give you an angle, and tangent will take you back again. So here, unlike the other two functions, we never have to worry about not being able to put a number in for tangent inverse because everything is in the domain of tangent inverse. We still do have the same thing that we did for sine and for cos, which is if you give an angle that's not inside this domain of negative pi over 2 to pi over 2, tangent will give you a real number, but tangent inverse won't give you your original angle back. It'll give you the equivalent angle in quadrant 1 or quadrant 4. So here we want to evaluate tangent of tangent inverse of negative 123.45. And for this, we know that the angle that the number that we've been given is inside the domain of tangent inverse. We were being given something that's a real number, and any real number is in the domain of tangent inverse. So tangent inverse will turn that into an angle, and tangent will give us our real number back again. So that means that tangent of tangent inverse of negative 123.45, we will get our input back as our output. Nice. For the second one, tangent inverse of tan of pi over 10, pi over 10 is inside that restricted domain for tangent, so it'll give us a real number, and tangent inverse will take us back to the start again. So if I put pi over 10 as my input, I will get pi over 10 as my output. So these were the two easier examples because for both of them we were putting in something that was in the restricted domain for tangent or something that was in the domain for tangent inverse. For the other two, we have a little bit more work to do because one is something where we are not in quadrant 1 or quadrant 4. 3 pi over 4, if we do a quick little sketch here on the side, that would be in quadrant 2. And if you're looking at 3 pi over 4, the reference angle is pi over 4. Now, in quadrant 2, we know that that's a quadrant where sine is the positive function, but that means that would be where tangent is negative. And so we know that for tangent, inverse, we're going to get something that's in quadrant 1 or quadrant 4. Quadrant 1, that's where tangent would be positive. Quadrant 4, that's where tangent would be negative. So the reference angle is pi over 4. We should be in quadrant 4, so that means the angle that we're talking about is negative pi over 4. So we know that tangent of 3 pi over 4 and tangent of pi over 4 are both equal to each other. They both have the same reference angle, and they're both in quadrants where tangent is negative. lost the negative there. I'll write that again. Better. So since negative pi over 4 and 3 pi over 4 both give us the same value for tangent, and since negative pi over 4 is in quadrant 4, it's in that restricted domain for tangent, then that means that'll be in the range for tangent inverse, that negative pi over 4 will be my output. There we go. One more, we have tangent inverse of tangent of 4 pi over 3. 4 pi over 3, if I do a quick sketch of that, 3 pi over 3 is the same thing as pi, so 4 pi over 3 is a little bit more than pi, and it's more than it by pi over 3. So my reference angle is pi over 3, and that would be in quadrant 3. Quadrant 3 happens to be where tangent is positive. Now, I know that tangent inverse will give me an angle in quadrant 1 or quadrant 2, but since I know that we are in an angle where tangent is positive, it'll give me my answer in quadrant 1 where tangent is also positive. So reference angle is pi over 3. We're in quadrant 1. That means we are the angle pi over 3. So tangent of 4 pi over 3 and tangent of pi over 3 are equal to each other, and so that means that we can say that if you put 4 pi over 3 as the input, tangent inverse will give you pi over 3 as the output. And that's because it gives you the same value for tangent, but it's in quadrant 1, which is part of that restricted domain for tangent, or the range of tangent inverse. All right, good work, everyone. We'll take one last break before coming back for the last part. And in the last part, we will talk about solving equations that involve an inverse trigonometric function. So we'll see you all in a few minutes.